A space object does not need to be alive to destroy Earth. It only needs mass, speed, and the wrong trajectory. Asteroid. An asteroid is basically a leftover rock from the construction of the solar system. Most of them stay in safe orbits between Mars and Jupiter, but some get pushed out by gravity, collisions, or close passes with planets, and then they become cosmic bullets. The scary part is not just the impact. A large asteroid hitting Earth would release more energy than millions of bombs at once. The ground would melt, shockwaves would flatten everything nearby, and if it hit the ocean, tsunamis could cross entire coastlines. But the real planet killer comes after. Dust and vaporized rock would rise into the atmosphere and block sunlight. Plants would die. Food chains would collapse. Earth would not explode. It would starve under a dark sky. And this has already happened before. But asteroids are not the only rocks Earth has to worry about. Some objects come from much farther away. Comet. A comet is not just a dirty snowball flying through space. It is a frozen leftover from the edge of the solar system, made of ice, dust, rock, and ancient material that has been drifting in the dark for billions of years. Most comets live far away where nothing much happens, but gravity can disturb them. A passing star, a planet, or another object can push one inward, sending it falling toward the Sun on a long, stretched orbit. That is what makes comets dangerous. They can arrive from deep space, from strange angles, and at extremely high speeds. Unlike many asteroids, some comets give us much less warning because they spend most of their lives far beyond easy detection. If a large comet hit Earth, it would be like an asteroid impact, but worse in one important way: speed. More speed means more energy. More energy means more destruction. The impact could throw dust into the sky, ignite fires, poison the atmosphere, and trigger a global collapse. But at least a comet has to hit us. The next object can destroy Earth without touching it. The Sun. The Sun is the reason Earth is alive, but it is also the closest object powerful enough to break the entire modern world. Most of the time, the Sun looks calm from here, a bright circle in the sky. But up close, it is a violent ocean of plasma, magnetic fields, and explosions larger than Earth. Sometimes it throws out massive storms of charged particles into space. If one of those storms hits Earth, the planet itself would survive. People would not instantly burn, oceans would not boil, mountains would not melt. But civilization could take the hit. Satellites could fail, GPS could disappear, radio signals could collapse. Power grids could overload and burn out. Cities could go dark, not for minutes, but possibly for weeks or months. The scary part is that the Sun would not be trying to destroy us. It would just be doing what stars do. But the Sun is still our star, and we know where it is. The next object can appear from darkness with almost no warning. Rogue planet. A rogue planet is a planet without a star. No daylight, no seasons, no orbit around a sun. Just a dark, frozen world drifting through space alone. And that makes it almost impossible to see. A normal planet reflects the light of its star. A rogue planet has no star to reflect. It could be larger than Earth, larger than Jupiter, and still move through the darkness like a shadow. The terrifying part is that it does not need to hit us. If a rogue planet passed through the solar system, its gravity could ruin everything. It could pull comets out of place, disturb asteroid belts, stretch planetary orbits, or even slowly drag Earth away from the safe zone around the Sun. Earth survives because it is in the right place, not too hot, not too cold. Stable orbit, steady sunlight. A rogue planet could turn that balance into chaos. And if Earth were pushed even slightly too far from the Sun, the oceans could freeze. Too close, and they could boil. But a rogue planet is still only a planet. The next object is a dead star with the mass of the Sun crushed into something the size of a city. Neutron star. A neutron star is what remains after a massive star dies and collapses. Imagine taking something heavier than the Sun and crushing it into a ball only about the size of a city. That is a neutron star. It is small compared to planets, but its gravity is insane. A single spoonful of neutron star material would weigh billions of tons. If one passed near Earth, the planet would not need to crash into it. The gravity alone could tear Earth apart. First, the oceans would rise in impossible tides. Then the crust would crack. The atmosphere would be pulled out of shape. Earth would stretch, break, and collapse under forces it was never built to survive. The scariest part is the size. Something that small could be one of the heaviest objects in the universe. But a neutron star is not even the most dangerous kind of dead star. Some dead stars come with magnetic fields so powerful they can attack matter itself. Magnetar. A magnetar is a neutron star with a magnetic field so powerful it almost sounds made up. A normal magnet can pull metal across a table. A magnetar can pull on atoms themselves. If one appeared too close to Earth, it would not need to hit us. Its magnetic field could destroy electronics, damage the atmosphere, and interfere with the basic structures that hold matter together. From a distance, it might look like a tiny dead star. Up close, it would be one of the most hostile objects in the universe. And magnetars can also release giant flares. These are sudden blasts of radiation so powerful that even from thousands of light years away, they can affect space around Earth. If one happened close enough, the radiation could damage the atmosphere and expose the surface to deadly energy. A magnetar is not just a dead star. It is a dead star that still has a weapon. But even a magnetar shines when it attacks. The next object can be almost completely invisible. Black hole. A black hole is not a giant space vacuum cleaner. It does not suck in everything across the galaxy. From far away, it acts like any other object with the same mass. But if one came close to Earth, the planet would be finished. A black hole is a place where gravity becomes so strong that even light cannot escape. That means once something crosses the event horizon, there is no path back out. Not for rockets, not for planets, not even for light itself. If a black hole passed near Earth, it could rip the planet out of its orbit, tear away the moon, or stretch Earth apart with tidal forces. One side of the planet would be pulled harder than the other, turning gravity into a planet-breaking machine. The worst part is that the black hole itself would be invisible. You would only see what it was doing to everything around it. But some black holes are even harder to notice, because they do not sit in one place. Wandering black hole. Most black holes are found because something around them gives them away. Gas heats up, stars whip around, light bends. But a wandering black hole moving through empty space could be almost impossible to notice. It would not glow, it would not have a surface, it would not reflect light. It would just drift through the galaxy like a silent hole in reality. And it would not need to hit Earth directly. If a wandering black hole passed through the solar system, its gravity could throw everything out of balance. Planets could shift. Asteroids and comets could be pulled into dangerous new paths. Earth could be pushed away from the Sun or dragged into a deadly orbit. The disaster might begin with tiny changes nobody understands. Then the moon moves wrong. Then the planets move wrong. Then Earth's stable home becomes a broken machine. A normal black hole is terrifying. A hidden one is worse. But the next object does not hide in darkness. It announces itself by exploding. Supernova. A supernova is what happens when a massive star dies violently. For millions of years, the star fights against its own gravity. Heat pushes outward, gravity pulls inward. But when the fuel runs out, gravity wins. The core collapses in seconds. Then the outer layers blast into space with enough energy to outshine an entire galaxy for a short time. If this happened close enough to Earth, the explosion would not need to touch the planet. The radiation could hit the atmosphere, damage the ozone layer, and let deadly ultraviolet light reach the surface. The oceans would not instantly vanish. The mountains would not explode. But life would begin losing the shield that protects it. Plants would suffer first, then food chains, then everything depending on them. A supernova is terrifying because it is not just a dying star. It is a star turning its own death into a weapon. But some stellar explosions are even more focused. The next one fires like a cosmic gun. Gamma-ray burst. A gamma-ray burst is not just an explosion. It is an explosion squeezed into a beam. Instead of throwing energy in every direction, it fires two narrow jets across space, like a cosmic gun shooting from the depth of a star. That is what makes it so dangerous. If Earth were in the path of one of these beams, the burst would not need to crack the planet open. It would hit the upper atmosphere with extreme radiation, damaging the ozone layer and changing the chemistry of the sky. From the ground, it might not look like the end of the world at first. There would be no giant fireball landing in the ocean, no planet smashing into us. But after the shield above us weakened, sunlight itself would become more dangerous. Radiation would reach the surface. Plankton in the oceans could die. Food chains could collapse. And the worst part is the warning. There would be none, because gamma-ray bursts travel at the speed of light. The moment we saw it would be the moment it arrived. A bullet from space that outruns its own alarm.